Hi students, today we're going to do Chapter 11, Section 1 Notes. Frame of reference. A frame of reference is a system of objects that are not moving with respect to one another. We actually use a frame of reference to detect motion. You just might not realize it. Relative motion is just movement in relation to the frame of reference. So you have a frame of reference that you use, and then you detect relative motion in relation to that frame of reference. One example would be people moving on a train or maybe a bus. So let's pretend if you're sitting on that train with another person and this person sitting next to you is sitting still because you're on that bus or the train, it doesn't look like that person is moving. However, because your frame of reference is on that train. However, if you get off of that train or bus and you're on the street and you watch the train or the bus go past you, it looks like the people on that train or bus, even if they're sitting still, it looks like they're moving because your frame of reference is now different. And so it does look like they're moving because they're inside the train. There is a video that we will watch tomorrow to help with frame of reference because I know it's hard to understand, but that video hopefully will clear everything up. Distance. Distance is the length of a path between 2 points. The SI units are m or meters, kilometers, or centimeters. We'll mostly work with meters in our class or maybe centimeters. Displacement. Displacement is a definition, so you should know that. It is measuring distance with direction. So there's a difference between distance and displacement. If I'm asking where am I if I walk 1 block, that would be figuring out the distance because there's no directions. So that's distance. But displacement has distance with direction. And so if I say where am I, because if I just say the distance one, I might go north, I might go west, I might go south, you never know. But if I say where am I if I walk 1 block north, this down here is displacement because it includes a direction. The biggest thing is displacements can be combined. So if you walk 3 blocks west to school and then 3 blocks east back home, you've walked a total distance of 6 blocks. So distance, you just add everything together. But your displacement is 0 because you end up back where you started. So if you go 3 blocks west and then 3 blocks east, the west and the east cancel each other out. Whereas distance, you just add everything together. So here's a practice problem, and you should try and do it on your own. What if you drive 1 mile north, 2 miles east, 1 mile south, and then 1 mile west? Tell me what the total distance is, and tell me how about the displacement. To figure out the total distance, you just want to add all of them together. So we've got 1 plus 2 plus 1 plus 1, and that is 5 miles. To figure out the displacement, you want to see what cancels each other out. So we've got 1 mile north. The opposite of north is 1 mile south. And since they're the same number, those cancel each other out. Then we've got 2 miles east and 1 mile west. Those are opposite of each other. Since this is a 2, whereas this is a 1, this whole thing is going to cancel out, and we're going to be left with 1 mile east, because only 1 mile will cancel each other out. So we will be left with 1 mile east.